Hello everyone, this is Sedi and welcome to Sedi's Mathverse. For today's video, we will discuss random problem 25, which is entitled Always Divide by 2. What are we dividing? Let's find out. Without further ado, let's get started. Here is random problem 25. What is the maximum value of the integer exponent k such that 2 raised to the kth power divides 20 factorial? If you want to solve this problem first, you can pause the video if give it a try. But if you want to view the full solution, continue watching. In order to solve this problem, we will present two different approaches. Solution 1 is directly factoring 20 factorial. 20 factorial, as we know it, is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12 times 13 times 14 times 15 times 16 times 17 times 18 times 19 times 20. Since we are only concerned about factors that have 2, we will remove the odd numbers. So we will just get the multiples of 2 for each factor, or the powers of 2 rather. For this, we have 2. For 4, we have 2 squared. Since this is 2 squared itself, 6 is 2 times 3, so we get another 2. 8 is 2 cubed, so we get 2 cubed. 10 is 2 times 5, so we get another 2. Then, 12 is 2 squared times 3, so we get 2 squared. 14 is 2 times 7, so we get 2. And 16 is 2 raised to the 4th power, so we get 2 to the 4th power. Then 18 is 2 times 3 squared, so we get another 2. And lastly, 20 is 2 squared times 5, so we get another 2 squared. And this is the maximum value of the integer exponent key that we desire. Using the laws of exponents, we will just add up each exponent. So we get 2 raised to 1 plus 2 plus 1 plus 3 plus 1 plus 2 plus 1 plus 4 plus 1 plus 2. And then add up these exponents. So we got 1, 3, 4, 7, 8, 10, 11, 15, 16, 18. So the correct answer is 18. But what if 20 was replaced by another larger number? Then this method will take a longer time. This leads us to the other solution. Solution 2. This solution uses the Legendre's formula. Legendre's formula states that the maximum value of k such that pk can be divided by n factorial is k equals floor of n over p plus n, floor of n ulit. This leads us to solution 2. Solution 2 uses the well-known Legendre's formula, wherein it states that the maximum value of k such that p, wherein p is a prime number, raised to k divides n factorial is equal to k equals the floor of n divided by p plus the floor of quantity n over p squared plus the floor of n over quantity over p cubed, and so on. So how will we use this formula to solve this problem? We have p, the prime number is 2, and n equals 20. We want to find k. So we have k equals floor of 20 over 2 plus floor of 20 over 4 plus floor of 20 over 8 plus floor of 20 over 16 plus floor of 20 over 32, and so on. Okay. 4 is 2 squared, 8 is 2 cubed, 16 is 2 raised to the 4th power, and 32 is 2 raised to the 5th power, and so on. I just simplify it so that it would be easier to divide. Then k is equal to floor of 10 plus floor of 5 plus floor of 20 over 8 is 2.5 plus floor of 20 over 16 is 1.25. Then 20 over 2 is floor of 0.625, and so on. As we can see, the floor of 10 is 10 since it is an integer, as well as 5. The floor of 5 is 5. The floor of 2.5 is the greatest integer less than or equal to 2.5, which is 2. Then 1.25 is the greatest integer less than or equal to 1.25, which is 1. For 0.625, it is 0. The floor is 0. And notice that 20, when we divide the other terms, 20 over 2 raised to 6 floor, it becomes 0 as it goes near and near 0. So we disregard the other exponents. And this leaves us with only 4 addends. 10 plus 5 plus 2 plus 1, which we obtain k equals 18, which is our solution for this problem. So both solution 1 and solution 2 gives us the answer of 18. So that is it for today's video, Mathverse. I hope you enjoyed and learned something from this video. If you did, please like this video and subscribe to my YouTube channel, Sedis Mathverse. Also, follow my social media accounts because I post content there on a regular basis. That's it, folks. This is Sedi, reminding you to chase your greatest moonbeam, and mathematics is incomplete without you. Till next time.